right, welcome back everybody. Hope everyone had a good night last night. We're going to jump right back into it. Once again, I'm Mr. Cooksey. Today we're going to be doing a little experiment. We're sticking with the law of conservation of mass, but today we're going to explore a chemical change. Yesterday we talked again about the law of conservation of mass, so let's review it together. This law says that matter cannot be created or destroyed. No matter what happens, the total amount of matter always stays the same. Even when it changes its form, the matter is still there, just in a different state or place. We also started talking about the differences between physical changes and chemical changes. Anybody want to try to sum that up into a short sentence? Go ahead, Leslie.
A physical change is when it doesn't change what it is, it just changes the way it looks. A chemical change would be it forms something.
Okay, so a physical change is when matter changes in size, shape, or state, but no new substance is made. And then, so one example would be tearing paper into pieces or ice melting, which we saw yesterday. A chemical change is when matter changes into something new, like Leslie said, that cannot easily be reversed. Burning wood or mixing certain substances together like baking soda and vinegar are chemical changes. Today we're going to see chemical change in action while also proving once again the law of conservation of mass. We'll do the experiment two different ways, an open system and a closed system. One where gas escapes into the air and one where we trap it into a balloon. I want you all to watch closely for evidence that matter is conserved. So here's the challenge. Can we inflate this balloon without blowing it up? And if we weigh the bottle before and after the reaction, do you think the mass will change? Let's start with our prediction question on our worksheet. You guys get together for a second, read the question, and make a prediction as a group. With the prediction, let's predict on whether or not it's going to increase and decrease with the balloon on and with the balloon off. And just write it down below the option. Okay. So you can just put BO next to that one and then BF. Balloon on, balloon off. Peyton, would you like to share what y'all's prediction were for today? Can you start with reading the question for me?
Do you think the mass will increase, decrease, or stay the same?
Okay, well, let's start with the balloon off. What do we think? Balloon off.
Decrease.
Okay, and what about the balloon on? All right, and then if you could read this top question for me and tell me what you got.
What do you think will happen when we mix baking soda and vinegar in a bottle? Once we mix
Okay, so what we got Mason's writing. I'm gonna need one person for the first part, the open system, to handle the vinegar and to dump the balloon in. I'll show you first, and we're gonna have to do it on the scale. So, we're not gonna tear this time because we wanna know, we don't care if we know the weight of the bottle. It doesn't affect whether or not we can find out the law of conservation of mass applies. So I'm going to take the lid off because we don't need that. And I am going to then put my vinegar, my balloon, and my substance on the scale, and I'm going to jot down. I got 144 grams. Alright? Then I am going to dump the contents of my balloon into the vinegar, like so. And then we're going to wait and let it continue to fizz and complete its chemical change. And it appears that I got 138 grams, so I'm going to write that down. Okay. And let's do the same thing, and y'all record y'all's results here. So be sure not to get you can use a funnel if you'd like, because the reaction came up into my balloon and wet my baking soda inside the balloon. So you might want to hold it a little higher. And we gotta get all our weights first. Feel free to talk, work together. Everybody has a voice.
See, I was right.
All right, we have our vinegar, we have our baking soda, and we have our balloon on the scales. Everybody confirm what you see, confirm we're still on grams, and then let's write that down on our data sheet. Oh, good catch.
Now,
So this is an open system, good job. All right, let's get that put in there. And it's got the back, or you can do it on the scale, off the scale, you just have to reweigh it afterwards. There we go, it's going in. I mean, note the reaction, note what you see, what you hear. So today we use a half a cup of vinegar and 2 tablespoons of baking soda. Okay, let's just work it through there. Give you something to use. Okay. All right, let's reweigh it. Okay, does everybody agree? All right, let's try with a closed system. Once again, Peyton, if you could dump that out for me. And if our dedicated vinegar person could work on getting vinegar back in there. Now we're going to do it as a closed system. We'll wait for everyone to come back. the same reaction, except for this time, get my scale tare, 0 grams, away. All right, I got 162 grams there. Now I'm going to dump my baking soda into my dump my baking soda into my vinegar into a closed system. All right, note the change. You don't have to note it yet on your paper because we're going to do it. You're going to do it yourself. All right, I got 159 grams. Still sitting at 159 grams. All right, let's do that again just to make sure that we get the same results. Here's your balloon. If you need help getting it over the top of the bottle, let me know. One person holds the bottle while the other person gets it over here. Grams. Awesome. Someone do the honors. There it goes. Don't touch it. We gotta get that good weight. So it appears we have 149 grams. So write that down. All right, so it seems here we've lost a couple of grams. Now, we just did this experiment and we've seen that we didn't lose any weight at all. So does anyone have an idea on maybe why that may have happened? Okay, but would it matter if it all got in there or not? Okay, so maybe it's possible we had a small gas leak. All right, hey, but that's why we did it twice, right? So we still know that the law of conservation of mass holds true. So in both trials, we basically got the same. In our second trial, we had a small mishap and we lost a gram. But whenever we did an open system, the mass seemed to go down, correct? That's because what happened to the gas? All right. In the second trial, we trapped the gas in the balloon and we saw the mass stay the same. This shows that matter cannot be created or destroyed. It just changes form. So you don't have to write this down, but what we have here is a chemical equation. And it's sodium bicarbonate, which is Na8CO3, plus baking soda. Oh, it's sodium bicarbonate is baking soda, plus acetic acid, which is the vinegar in this case, CH3COOH. And when they're added together, they form carbon dioxide gas, right? CO2, H2O, which is water, and sodium acetate, which is CH3COONA. So as you can see from the equation there, we started off with 2 compounds, we had a reaction, and then we had 3 totally different compounds, which makes it what kind of change?
Chemical change.
Let's go back to our paper here and let's let everyone look at it. So just a few questions to think about while we look at our sheet. Why do you think scientists need to trap all the matter in their experiments? And what might happen if they don't? Inconclusive? need to trap all the matter in their experiment so they can measure everything that's there. If gas or liquid escapes, it looks like some of the matter disappeared, but really it just left the container, like we seen with our leaky balloon. If they don't trap it, the results can be misleading because the mass might look smaller and they might think that matter was destroyed when it actually wasn't. So in our worksheets, we recorded the mass for both trials. We wrote a short explanation of how the experiment shows the law of conservation of mass. I want you to also be sure to also explain why this was a chemical change and not just a physical one. So let's go to our sheets for our exit slip as a group today, and we're going to answer these three questions. Did the mass change in trial 1, open system? Did the mass change in trial 2, closed system? And how does comparing these two help us prove the law of conservation of mass? And I'll give you a few minutes to